Good morning everyone. So we are back with our physics class, and as you know that when I start the class, then I expect that your personal chats like where are you from, I am from Gudivada, or I am from Sikkim, or I am from Vizag, these should be given full stop, otherwise simply removed from the class. So whether it is offline or online, I am very strict about it. Shubho Shakal sir, okay, good morning to you, Surendra Babu. But everyone, now focus here, and good morning once again. Chalapati Korra, please wake up. Good morning, ma'am. Ma'am has gone. Now sir has come. Okay, so all the unnecessary chats, kindly put a full stop to it so that you stay in the class. And we are going to see something very important from the point of view of physics, because to understand physics we need the help of mathematical tools, and one of the most important mathematical tools used for understanding physics is what we call as calculus. Yes, calculus. So what is calculus? Let's see that. Which campus I am going to teach, that is a different issue, or something which you will come to know when you will come over here in Vijayawada. So presently focus on the class. When you come to Vijayawada, you can ask if you are joining over here, and you can ask anyone, they can let you know where I will be teaching. Okay. So calculus is a branch of mathematics which deals with something we call as change and rate of change. So what is calculus? It is a branch of mathematics dealing with change and rate of change of any physical quantity with respect to some other quantity. So in calculus we study about, Navya, if you don't want to be out of the class, stop your messaging, Telugu and Bengali or English, focus on the class, or you will be simply removed. This is the last time I am telling. So this is the branch of mathematics that deals with change and rate of change of any physical quantity with respect to some other quantity. We have seen before this some types of changes or rate of change, like rate of change of position is called velocity with respect to time. Rate of change of velocity with respect to time we call as acceleration. So when we are interested in finding that how things are changing mathematically and by what rate the changes are observed, that study is what we call as calculus. Now this calculus, it has been divided into two parts. First is called as differential calculus, where we study about rate of change, changes and all. And second one is what we call as integral calculus, where we find the total change or areas, volumes, etc. So basically, kindly remove Navya. I think he or she, whoever is either she or he is not able to see or hear properly. That's why please remove. So differential calculus mainly deals with rate of change, and integral calculus deals with overall change in any physical quantity, area, volume, length calculation for different curves or surfaces. We can find length, area, volume. So there is a mathematical tool which is called as integration. So integral calculus deals with overall change. What is the overall change brought in any physical quantity? Obviously it will be when we study mathematically, it is area under graph, but it also deals with finding area, volume, length. So these all type of calculations are also observed or done with the help of integration. And in differential calculus, we deal with the rate of changes. Okay. So let's see, today's class we will be seeing, since it is a tool, we will not go to too much of depth, but we will see what all things we have to use in physics, and one or two I will derive and show that how basically the formula for differentiation comes. Important derivatives or differentiation we should know. So we start with differentiation. So in differentiation, first of all, when I said that we are dealing with change and rate of change, so before this I told you different examples of functions where I said that there is an equation relating two variables y and x. We call this mathematical relation as a function. So what we say, if we write y is fx, that means variable y is a function of x. What is the meaning of the word function? Kindly remove Sudhakar also. Sudhakar Reddy, he is also not interested in class. So same old rant is going on, when classes will continue, where what will be done and so on. Removes is a function of x. When we say something is a function of x, that is continuously varies with x. So when something continuously varies with x, then we say that it is a function of x. Now here, when we write as a function of x, this is the symbolic representation. We say y is f of x is function of x. Here there are two variables or two physical quantities, you can see, one is y and one is x. So here x is called as the independent variable. This can take any value. So there is one variable whom you can give any value, and depending on that value you will get different values of y. So when we write y is a function of x, x is called as the independent variable to which we can assign any value. On the other hand, the values of y will be found only when the values of x are known. So this y is called as the dependent variable. So it depends on x, so we call it as dependent variable. If you somehow swap them, if you make x as a function of y, then y will become the independent variable and x will become the dependent variable. So whenever we are writing any function, what we do, we take the dependent variable on the left hand side and the independent variable on the right hand side. Then we are getting a function. So yes, this is derivative only. Differentiation is also called as derivative. We are going to see that. See, so y is function of x. This is the mathematical representation. So as I said that change in x, if you take any change in x, we denote it as delta x. We will denote it as delta x. And as x will change, obviously y will also change. Corresponding change in y due to change in x is delta y. So this delta x is also called a gap or interval of x. So when we have two variables, then when the independent variable, we consider a small change or a large change, whatever it is, we denote the change as delta x. And correspondingly y will also change. Why will y change? Arey, what is this Shravan continuously telling not visible, sir? Nay, one more student is telling it's your network. Okay, it is clearly visible, fine. So Shravan, if it is not visible, I think there is some network problem with you. Don't keep on repeating the same message again and again. It is your network problem. Stop replying unnecessarily. You have been told. So here change in x denoted as delta x, corresponding change in y is denoted as delta y. When we are saying delta x, whenever we take any interval, so what we say that delta x means the final value minus initial value, and delta y is final value of y minus initial value. I denotes initial, f denotes final. So these are what we call as change. Okay. Now we will use one more term. What is that? If suppose I have two values of x, this gap I am taking as delta x. This gap I am taking as delta x. Suppose I take two values. Now you can see that if this gap, suppose I am taking 2 points on x axis, one is this point and one is this point. So you can see there is a gap in x. Now if I make this gap very small, not exactly 0 but very small, as delta x becomes very small, that is this symbol we are using, which is called as approaches 0. So if delta x approaches 0, so can we say interval becomes instant? Almost. Now what do you mean by interval? Interval is a gap. Yes, correct, tends to or approaches. Interval, gap that becomes smaller and smaller. So what happens finally? It becomes, if the gap becomes smaller and smaller, instead of interval you get a single point which is called as an instant. So interval becomes what? Instant. So when the change in x is very, very small, when the change in x is very, very small, we give it a name. That change delta x, when it is very, very small or negligibly small, we call it as infinitesimal change in x. We will not call it equals to 0. Mind it is not equal to 0. It will be called approaching or tends to 0. So what we say, again, for any function y is a function of x, if x changes by delta x such that delta x tends to 0, then we denote delta x as dx. We will call it as dx. This dx is known as infinitesimal, which is very small change in x. Then the change in y, that is delta y, is also very small and represented as dy. So then it will be represented as dy. We don't call it as infinite. There is a difference between infinite and infinitesimal. Infinite means very large and infinitesimal means very small. This is the difference between the two words. Understood? Infinite and infinitesimal are not the same thing. We have just started. I think this guy is not interested in studying, and we have just started the chapter. Sir, when we will use differentiation, when we will use integration? Things are coming gradually. Don't be in a too much of hurry. When a food is cooked, it is supposed steaming hot. You just don't devour or eat the entire thing at a single instant. You take it sip by sip. If it is a hot drink or if it is a very hot food, you will eat it slowly. You won't gulp it the entire thing at once. So same is with physics also. Handle it carefully, otherwise you will burn yourself. Okay. So don't try to be super active that I will understand everything at one go. It takes time. So here the change in x and change in y, when they are very, very small, then in that case we call them as infinitesimal change. Now in such case, what happens? When we write delta y by delta x, delta y by delta x, it is the change in y with respect to change in x. It is called average rate of change of y with respect to x in a given interval of x. Just like we have studied rate of change, velocity, speed and all, you saw average instantaneous. Now we are going to see them again. Delta y by delta x, when you write change in y by change in x, okay, change in y by change in x, so it is called as average rate of change. It is known as average rate of change of y with respect to x in a given interval. Now, when we are writing that as delta x tends to 0, means I said interval will approach instant. Interval will approach instant. So in that case, what will happen? Delta y by delta x will become dy by dx. So when the change in x is considered very small, then delta x is dx, delta y is dy, then dy by dx, average rate of change will become dy by dx, which is called instantaneous rate of change. Means what I was talking about earlier about instantaneous velocity, instantaneous speed, these all will come from here. So when we are saying that the interval in x where you are considering a change in y, if that interval is very small, the interval becomes instant, and if the interval becomes instant, so the average rate of change, which is always calculated in interval, it will now be calculated at an instant, and that is called as dy by dx or instantaneous rate of change. So basically dy by dx, which we call also as differentiation or derivative, is nothing but the instantaneous rate of change of any physical quantity y with respect to x. Understood? So presently I am dealing with the theoretical things first. Understand the definition. Understand the definition. So when we are, last time I am repeating, when delta y by delta x is considered, delta x is a change in x, corresponding change in y is delta y. The rate of change, that means delta y upon delta x, is called average. It is always found in a interval or gap. But when the gap becomes very small, not exactly equal to 0, very small, then you are approaching from interval towards an instant. So in that case, the average rate of change also approaches what is called as instantaneous rate of change, and the symbol used for that is dy by dx. Understood? So this is what we call as differentiation. So if now I write for a function, again I am writing for a function y is a function of x, rate of change of y with respect to x, WRT I am writing short for with respect to x, at any particular instant or value of x is dy by dx, also called, different names are there, differentiation of y with respect to x, or derivative of y with respect to x. So two names we use. It is called differentiation of y with respect to x or derivative of y with respect to x. So it is nothing but the instantaneous rate of change. We have a symbol dy upon dx, and average and instantaneous rate, how we relate them mathematically. Mathematically we also say, when we take average rate delta y by delta x, this is the average rate, we use a symbol LIM, delta x tends to 0. This LIM stands for limit, means we are limiting the value, delta x tends to 0, it becomes very small, then this is represented as dy by dx. This is a mathematical way. If you want to explain something just to any person who knows a bit of mathematics also, so they will understand what you are talking about. When we are saying limit delta x tends to 0, means you make the gap almost negligible or infinitesimal small, then the average rate of change will become instantaneous rate of change. Okay. So we have some important functions which I have told you, all the important functions I have told you by graph also. Remember, we saw polynomial functions like quadratic function, we saw straight line function, we saw their graphs, parabola, then we saw straight line, we saw rectangular hyperbola, we saw circle, we saw ellipse, all this thing. So delta y and dy beta I just told, when we are seeing any change, this symbol in Greek letter is delta, capital delta. When we are taking any change, we use it to show the change. Delta means change. But when we are writing d, it is a infinitesimal or negligibly small change. So that is denoted as dy. Now don't be surprised that sir, dy is so very small, dx is very small. That means dy by dx should also be very small. No, don't be confused by that thing. dy, dx are very small, infinitesimal small, but their ratio will not be small. Just I will take 1 second to explain you. Suppose I say dx is 0.0001, you will say sir it is very small, and correspondingly dy is also very small. Suppose this is 0.0002, but if you divide both, will you get a small change? See here, if you divide both, you will get 2, which is not small. So delta, again telling, delta is a change. When the change is very small, approaching 0, then we denote it as d, which is infinitesimal small change. But when we are writing delta y by delta x as dy by dx, that doesn't mean that dy by dx is also very small. dy by dx may be small, large, it can have different values. So dy by dx value, you can see this example, you are seeing that even though these two were small, but the ratio was not small. Understood? So now we will see some important mathematical functions and what are their derivatives. So now onwards, when I use the word derivative, so you should understand derivative is nothing but the other name for differentiation, right? And I will show you one formula which everyone would be knowing, x to the power n. Beta, you know, when we have x to the power n, can anyone tell, those who have studied earlier, what is the derivative or differentiation of x to the power n? What is the differentiation formula? Anyone knows? I want to just hear from you, then I will show you. This one I will prove also and show. Yes, nx to the power n minus 1. Very good. Now let's see that it is not just a random thing. It comes once again. Those who don't know, let's see how it comes. Important derivatives. First, if y is dependent on x, function of x, and this function is of the form x to the power n, where n is any constant, n is any constant. It can be an integer, it can be a fraction, whatever. If n is a constant and x is the variable, so x is variable and n is constant. If n is 1, it will become linear equation. If n is 2, it will become quadratic equation. If n is 3, it will become cubic equation, and so on. So if it is of this form, then dy by dx, which is the rate of change of y at an instant, dy by dx, this is nx to the power n minus 1. Nx to the power n minus 1. Now nx to the power n minus 1 means you will just multiply the power outside and make the power decrease by 1. First I will show you examples and this one I will show you the proof also. Very, very important. Example, if y is x square, so I can say dy by dx power is multiplied 2x. If y is x, power is 1, so I can write 1 will come outside and x to the power 1 minus 1, that is x to the power 0. X to the power 0 is how much? 1. So when you differentiate x with respect to x, you get 1. Not only this, you can have any power. If you have y is equals to root x means when you are writing dy by dx, so root x can be written as x to the power 1 by 2. So I will first multiply the power outside. Just see the formula. Power is to be multiplied outside and subtract 1 from the power. So you can see it will become x to the power minus 1 by 2 by 2. So if you take it down, it will become x to the power 1 by 2 in denominator, which is nothing but root x. Correct? X to the power minus 1 by 2, when it comes down, it will become x to the power plus 1 by 2, and that means nothing but root x. If you see y is equals to 1 by x, you can take it up, x to the power minus 1. So dy by dx will become minus 1 x to the power minus 1 minus 1, that is minus x to the power minus 2, which you can now take down minus 1 by x square. So these are different examples which I showed here. First, this thing should be clear, important derivatives. So the first important derivative that we are seeing is that if you have y of the form x to the power n, where n is any constant and x is variable, so dy by dx or the rate of change of y with respect to x at any given instant is this value. Is the formula first clear to all of you with the examples or applications examples? Now I will show you how this formula comes. Please, I like to see response from all of you that you understood this, the application part. Now we will see how this formula comes. So if you remember, when I started the classes, taking the classes, in the beginning I told something about approximations. We take some useful approximations. If you remember, I told two approximations. One was binomial approximation, one is trigonometric approximation. Remember, 1 plus x to the power n, I could have written as 1 plus nx. 1 plus nx. Sir, in third example, minus not kept. Where did I not keep the minus, beta? Third example, x to the power 1 by 2. So 1 by 2, x to the power half minus 1. Half minus 1 is minus half, and when you take minus half down, it will become plus half. Plus half is nothing but root x. Where I did not keep the minus, beta, check properly. Charitra Reddy. I hope you will identify what you are trying to say, and for rest, I hope it is clear. So I was talking about binomial approximation. So I said that if you have 1 plus x to the power n, and if x is very, very small than 1, then we can write 1 plus x to the power n as 1 plus nx. This I said is binomial approximation. Understood? So let's use that, and this principle by which we find differentiation, it is called as differentiation by first principle. It is known as first principle. So proof is by first principle. The method of proving is called first principle, or there is another name for it in mathematics, ab initio method. So when we prove any differentiation, the method is called as first principle or ab initio method. ab initio method. So what it says, let's try to understand. Y is x to the power n. Okay. Now what I am doing, suppose I change x. So y is a function of x. So if x is changed by delta x, so we know y changes by delta y. So we can say new value of y will become new value of x to the power n. Arey bhai, when y is x to the power n, so when I say a new value of y, it will be new value of x to the power n. Now let's put the new value of y. Y has changed by delta y, so new value I will write as y plus delta y. And here new value of x I will write x plus delta x power n. I hope no problem in this. Now what I am trying to do, let's see here. This is first equation. This is our second equation. From here I am taking something common outside. See properly. I will take x common. If I take x common, what will be left? 1 plus delta x by x. Array, if you multiply and see, you will get this only. X into 1 is x, x into delta x by x is delta x. But here you have power also. So I have just taken common. Can you see? I hope this much part is clear to all of you. Now, delta x tends to 0, then we know if the change in x is very small, delta x becomes is replaced as dx and delta y is replaced by dy. We told this. So let's see what you are getting. Y plus delta y will become dy. X to the power n as it is. Now see here one interesting thing. If delta x is very small, so can you see delta x is very small, this term will become very small than 1. This term will become very small than 1. So if it becomes very small than 1, then what we can write? I can just multiply the power over here, 1 plus n times delta x by x. Beta, don't put your mathematical inputs. I know what I am doing. Sir, I have taken z both sides power. Array, see properly. Here only I took n x to the power n common. We got this. Focus here instead of putting your own valuable inputs right now. So we are getting y plus dy is x to the power n. Here I applied what is called as binomial approximation, which I discussed in first class. I said that if you have 1 plus something to the power n, array delta x, Yoshita Reddy, I think you were scrolling somewhere and you suddenly entered the class. I have explained already in the beginning of the class. Throughout I have been explaining what is delta x and dx. So please don't be bothered over here. So here, now when delta x by x is very, very small. I have said it is tending to 0, very, very small. So if it is very small, then 1 plus small value to the power n by binomial, we know that power just gets multiplied. When you will listen to the previous class of mine, there I have explained binomial approximation. So you can relate with that. So power gets multiplied. Is it clear? See this step properly. Is it clear? And I told dx, I will replace delta x by dx. So now what I am doing is, I will write y plus dy is equals to x to the power n 1 plus, I said that when delta x is very small, I take it as dx. So delta x I can write as dx also. So n dx by x. Final thing, I will just break the bracket. I will get x to the power n plus, break here also, n x to the power n by x. See here, x to the power n by x, x to the power n by x, x to the power n by x. 4 times I told. So x to the power n minus 1, and there is a dx also. Now if you see the first equation, what is y equals to? Y is equals to x to the power n. So in place of y plus dy, I can write x to the power n plus dy or not. From equation 1, in place of y, can I write x to the power n? So you will see x to the power n cancels. So I will get dy is equals to nx to the power n minus 1 dx. And finally, the last nail in the coffin, dy by dx, nx to the power n minus 1 is our formula, which is called as first principle or AB initio method of finding derivatives. So it is not that things randomly come, everything has a proof, but for all we do not have to derive everything, just we have to see the formula of differentiation. It is a mathematical tool which we are going to use. So nx to the power n minus 1 is the differentiation or derivative of x to the power n. Please respond if you have understood, and I think some new candidates are again coming out who I think have not listened to what I have told in the class, that don't involve yourself in unnecessary chats while I am teaching. Okay, be students while you are studying, be students who are there to accept any information or knowledge given to you. Don't be the frogs who during rain time you will see, okay, wherever you will see lot of water has accumulated there, frogs will keep on giving out their typical sound. So don't be frogs. You all are born human beings, we all are human beings. A human being is teaching to you, you are human being listening to the teacher. Don't unnecessarily waste your time, and again that what is your name, what is my name, you are from here, I am from there. All those things you can do when you are free, not in the class. So here dy by dx is nx to the power n minus 1. So based on this, we have some very important formula which I am going to enlist right now. So everyone, let me tell you, they are all derived by AB initio method, but we won't be wasting time in deriving them now. I said you what is the method. Now we come to the standard formula that you have to remember. Other important derivatives. So for different functions, the basic differentiations that everyone should remember. Number 1, if y is equals to sin x, then dy by dx means differentiation of sin x with respect to x. This is cos x. The rate of, that means we can say the rate of change of sin x with respect to x is cos x. Yes, the formulas which I am going to write over here, this you have to learn. You don't have any option. You cannot run or hide everywhere. You have to learn a few things. So when I say y is sin x, the rate of change of sin x with respect to x is cos x at any instant. Second, if y is equals to cos x, then rate of change of y with respect to x is minus sin x. Rate of change of y with respect to x, if y is cos x, it is minus sin x. So here there is a tricky part. Sin differentiation cos, cos differentiation is not sin, minus sin. Third one which you have to remember, all I am telling such forms which you have to remember. Y is equals to tan x. Then dy by dx is secant square x. Secant square, just not secant, secant square x. Dy by dx is secant square x. So these are the by names which you have to remember. Then there are any other differentiation, there are some rules, techniques which we will be discussing in next class. You can find every differentiation, but few you have to remember. Okay. If you are asked what is 3 into 4, 3 fours are how much? You won't derive and find that it is 12. You will simply remember mathematical tables, multiplication tables you have learned. You remember that. So there are some things which we are supposed to remember. You don't keep on deriving every time. So these are the values you are bound to remember. So secant square. Fourth, y is equals to cot x. This derivative is cosecant square or cosec square x, but with a minus sign. In cot x you have differentiation as minus cosecant square x. Tan it is just sec square x, cot it is minus cosecant square x. Yes. Fifth one which you have to remember, we have studied log x or natural log x. In last class we had discussed about everything. So natural log x, which we know is also represented as log x to the base e, then its derivative is 1 by x. So the derivative of log x, natural log that too, not normal log, it is 1 by x. And one more value which you have to remember, y if it is exponent e, Napier's constant or base of natural logarithm e, which also we had discussed in last class. When it is e, then its derivative is also the same. So this is what we call as derivative of e to the power x. It is same, e to the power x only, no change in that. So these are some formula which you have to remember. Understood? So these are some formula which you have to remember. So you can take a screenshot of the same: sin cos, cos minus sin, tan secant square x, cot minus cosec square x, natural log x 1 by x, and e to the power x remains e to the power x only. Okay. So towards the end, just I will tell you one or two simple techniques or rules. For differentiation. The important rules, first one, if y is equals to a constant, So if something is constant, what does that mean? Something is constant means it will not change. If it will not change, that means the rate of change will be 0. So when something is constant, it will not change, so rate of change is always 0. Second, if you have y as a function of x, it can be any function, but you see some constant is multiplied outside. C is a constant and this constant is multiplied outside. Then if they ask what is dy by dx, so you will treat the constant as it is. You won't change it anywhere, you will keep it as it is and you will differentiate the function. You will just differentiate the function. See here properly example. Suppose I have y is equals to 2x cube. So if I want to write dy by dx, I will take this 2 outside and I will just see the differentiation of x cube with respect to x, which I know x cube differentiation will become 3x square. So 3 2s are 6x square will be the answer. Simple. If y is, say, 1 by 2 x to the power 4, dy by dx simply 1 by 2 as it is, x to the power 4 will differentiate become 4x cube, so it will become 2x cube, just like this, etc. So whenever we have constant, then we do like this. If x is equals to 0, then what? If x is equals to 0, then what? You will be given a function, first you will differentiate it and then put the value of x, that's it. Understood? If you have been given any function and then they say that what if x is 0, when you are finding at any instant or any particular value, you will get like that. Just see here. Suppose if y is a function of x is given and dy by dx at a particular instant or particular value of x, suppose I call it as x1, is asked. Suppose they give you one function and then they say tell me what is the value of dy by dx. So the student who was telling that what if x is equals to 0, I am trying to make that clear for you. Focus here without any extra inputs presently. Y is a function of x and they ask you dy by dx at a particular value of x. It can be any value. What you have to do? Find dy by dx first and then put x is equals to x1. Example, if they give y is equals to 3x square and they say find the rate of change at x is equals to 0, x is equals to 1, x is equals to minus 2, suppose 3 values they are asking. So see what you have to do. What you will first do? Simply find dy by dx. Dy by dx will become 3 2s are 6x. Now put 1 by 1. Therefore, number 1 at x equals to 0, dy by dx will become 6 into 0. You will put the value finally. When you are asked x is equals to 1, dy by dx will become 6 into 1. When they are asking x is equals to minus 2, dy by dx is equals to 6 into minus 2, which is minus 12. Understood? So don't be bothered about what if x is equals to 0 or what if x is equals to non-zero. First, find the differentiation. Whatever you know, the formula for differentiation, find the differentiation. Then one by one, whichever value of x they have asked, just substitute it over there. Is it clear to all of you? So 2-3 points extra which I told, and I am ending the class over here. We will be having a discussion of the other rules of differentiation, and we will see that even if the differentiation is appearing to be very heavy, very big, in 1 or 2 lines or very quickly we can find the derivative or differentiation. And why we are finding differentiation, you got a glimpse of the role of differentiation when we studied about mechanics kinematics, where I said velocity, speed, all these values are found by using the concept of differentiation. Wherever we have instantaneous rate of change, that means there is differentiation. So we have to learn differentiation also, integration also. Yes, Sandeep, there is no relaxation. You cannot escape from integration. We have to learn, beta. No other option left. If you have to study physics, you have to study differentiation and integration also. Anna, I'm very sorry for feeling bad for you or sorry for you that you have to learn so much, but you don't have an option left. If you are preparing for NEET or JEE, you have to study differentiation and integration both. So that will be all for today's class. Hope you understood what I told. If yes, then you can share with your friends and ask them to subscribe, and we'll meet in the next class. Till that time, have a very good day. Thanks to all of you.